Hello everyone, welcome to VLSI Career Craft. Today we'll solve an interesting example on the concept of static timing analysis. In the previous example, we have seen how to calculate minimum clock period when there are two flip-flops and there is a combinational logic between them. So what if more than two flip-flops are given? That is, if the circuit is having more than two pipeline stages, how do we calculate minimum clock period? So let's get started. So in the circuit, flip-flop 1, flip-flop 2 and flip-flop 3 has identical setup, hold and clock to Q. And there are three combinational logics in the circuit and T skew is also given. So here we need to consider three cases. Case 1 will consider these two flip-flops and the logic between these. And case 2 we consider this part of the circuit, and case 3 we consider this part of the circuit. So for all these three cases, we calculate minimum clock period and come to a conclusion on worst case. What is the worst case? So let's calculate it for case 1. This is the circuit and T skew 1 to 2 is given. Pretty straightforward. It is minus 100 picosecond. So let's just substitute all these values here. T clock to Q is 140 picosecond plus T max is 1100 picosecond plus T setup is 40 picosecond and Q is minus 100 picosecond. So this is nothing but 280 picosecond plus 100 . So here T clock should be greater than or equal to 1380 picosecond. So this is from the first case. Now let's see what is the second case. For case 2, we calculated for flip-flop 2 and flip-flop 3. So here we have all the delays, combinational delays, but T skew is not given. So how do we calculate this skew? We need to come to a conclusion based on the skews which are already given. T skew 1 to 2 is nothing but T2 minus T1. We need to always do capture minus launch. 100 picosecond. T skew 1 to 3 is given, which is equal to T3 minus T1. 50 picosecond. Again, third flop is capture and first flop is launch. So let's say this is equation 1 and this is equation 2. So for this part of the circuit, we require T skew 2, 3. That is T3 minus T2. So if we subtract these two equations, 1 minus 2, what do we get? T2 minus T1 minus T3 plus T1. So T1, T2 gets cancelled. So we are left with T2 minus T1 equal to minus 150 picosecond. But we require T3 minus T2. So how do we if this is minus 150, then this should be 150 picosecond. Okay. So T skew, we have found T skew. So based on this, let's calculate the T clock. T max of the combinational circuit is 700 picosecond and setup is already given. T clock plus Q is 150 picosecond. So here 880 picosecond minus 150 picosecond, that is 730 picosecond. This is the conclusion from case 2. So now let's solve case 3. For case 3, here flip-flop 1 is capture and flip-flop 3 is launch. But this Q is given reverse, like T3 minus T1 is given. So we require T1 minus T3, that is equal to minus 50 picosecond. So let's again substitute the values. Here combinational logic maximum delay is 800 picosecond plus T setup is 40 picosecond. (980 picosecond plus 50. So this is the clock period from case 3. So based on these 3 cases, we need to come to a conclusion for what is actual minimum clock period required for this circuit. So from the first case, it is 1380, 730, case 3, T clock should be greater than 1030 picosecond. So these 3 equations will be satisfied only if we consider the worst case value, that is 1380 picosecond. Therefore T min is equal to 1380 picosecond. So this will be your answer. And if in case you were asked to calculate maximum clock frequency, you need to just take the reciprocal of this T min and you'll be able to get F max. So yeah, this is the procedure. We solve the circuit when there is more than 2 stages of pipeline. So thanks for watching. Please subscribe for more videos. Thank you.